Hi everyone, so this is day one of our 42-day revision challenge, and I'm excited to start off this with our first concept, which is the production possibility curve, also known as the PPC. So what is PPC? Let's define PPC. Well, PPC is simply an economic model that shows the maximum output of two goods that an economy can produce by employing its resources fully and efficiently. So what do we mean by this? Well, simply that, let's say we have an economy and it's making two resources, right? Let's say they're making apples and oranges, right? And let's assume that they employ all their factors of production, your land, your capital, your labor, your enterprise, fully and efficiently. So if there are only two goods that economy is making, and let's say they employ their resources fully and efficiently, then the PPC, or the production possibility curve, will shows you all the maximum possible output of these two goods, the various combination of these two goods that an economy will make if it uses its resources fully and efficiently. Let's show this in terms of a diagram. Okay, so on my x-axis, let's put oranges, and on my y-axis, let's put apples. Okay, so let's start with that. So on my x-axis, you have oranges, and on the y-axis, we have apples. So the first assumption we're taking is basically that only two goods can be made. Number two, another assumption that I'll take is just that when we're making this curve, we're assuming that the factors of production are fixed. This means that they will not change, because if they change, something will happen to the curve, which is a later discussion. So when we assume that all factors of production are fixed, and assume that the economy is making only two resources, and let's also assume there is a fixed technology. Things like machines are not increasing in their productivity, or workers are not becoming better, so technology is also fixed. So if we assume that technology is fixed and factors of production are fixed, and that the economy is using its resources fully and efficiently, and is making only two goods, then we get a curve like this, for that matter. Okay, we'll talk about the shape in a little while, but what is more important to see is that we are assuming that if an economy is, let's say, on this curve, let's say the economy is at point A, right? And let's say point A is like 50 of this, 50 of apples, and 15 of this, then the economy is basically getting this output or combination, but it's using its resources fully and efficiently. Now, if the economy wants to, let's say, decide we want more of oranges, what do? They simply decide to go from point A to point B, which would give them, for example, more, like the 25 of oranges. So this is plus 10, but they will then have to sacrifice something of apples, let's say 10 of apples. And the reason why they need to sacrifice is that when they move from A to B, they are devoting some of the resources that were going to apples. Remember, we've used all our resources fully and efficiently when we were making this combination A. Now, moving to B would mean take some resources away from apples and give it to oranges, which would mean sacrifice some of your output that you made for apples and get more of oranges. So there is clearly what we call your opportunity cost is happening, because when you lose something of your one good, you're getting another good in return, only because both these combinations were assuming resources are fully and efficiently employed. So there's one thing to start off with, that when you are on the curve, let me write this, all points on the PPC are where resources are fully and efficiently employed. Okay, while let's talk about what if you're not on the curve, and what if you are, for example, like at point like this one. Let's call this point X. Okay, point X is like where you are not on the curve, but you are under, below the curve. What does point X represents? Well, point X represents what we call inefficiency or unemployment. Now, let me explain this quickly. Let's say if you were at point X, right? Now, when you're at point X, and I'm saying this is inefficiency or unemployment, and the reason why I say that is that when you go from point X to point B, do you get more of oranges? And the answer is yes. I get 10 of more of oranges. But how much do you have to lose for apples? And the answer is, well, I'm not losing anything because it is 40-15 of apples and oranges, and now I'm going to 40 of apples to 25 of oranges, which would mean more of oranges but no sacrifice of apples. This means you must not be allocating your resources properly to start off with, otherwise you would have gotten some sacrifice. So point X basically represents that you were not employing your resources properly, because if you get more of something, let's say more of oranges, without losing anything of apples, then this would mean you had some unemployed resources which you were not properly utilized before or not utilized before, and now you're using them better. The last concept that we want to talk about on the PPC is basically, what about all the points which are not on the curve? Let's say all the points which are here, like for example, let's take a point like I don't know, let's call it Y, which is beyond the curve. Any point which is beyond the curve means what? Well, it means that you, even by utilizing your resources fully and efficiently, was unable to attain this point. If all the points on the curve shows you kind of like full employment, shows you your productive potential because you're using your resources fully and efficiently, and then you get these resources, then all the points which are not on the curve, let's say point Y, would be one where we say this, that it is an unattainable combination. With your given resources, with your given unattainable combination. Yeah. So with your given resources and with your given technology, you can't be at point Y. It is like unattainable. But tomorrow, let's say, if you become better, you might go to Y. But right now, you are stuck at this yellow line, which is your production possibility frontier or production possibility curve. So what is PPC? In short, it shows you the productive potential of an economy, right? It shows you, given your resources are fully and efficiently employed, right, productive potential. If your resources are fully and efficiently employed, how much of two goods that we can get, and whenever we are getting more of one good to less of another, we are making a sacrifice. And the reason why we make a sacrifice is because all resources are fully employed. So when you when you want more of one good, you have to give up something of the other by diverting resources from one production to another. Okay, and all points not on the curve but under the curve shows you inefficiency and unemployment, while all points to the right, which is beyond the curve, shows you unattainable combinations, which given with the given resources and technology cannot be attained. Now let's talk about how the PPC shows us the concept of scarcity, choice, and opportunity cost. So what is scarcity? Scarcity is simply unlimited wants and limited resources. So because of this unlimited want and limited resources, we know that there are some output combinations that we can't produce. In other words, some output combinations would be such that we do not have the resources to produce. They will be what we call unattainable. And therefore, if they're unattainable, then our PPC diagram can show that, because all combinations which are beyond the PPC, like for example, like let's say this combination Y, which is let's say 30 of oranges and 40 and 50 of apples, will be what we call unattainable. And the reason is very simple, because the economy doesn't have the resources to produce that output. So scarcity is shown by all combinations to the right of the PPC, which are all the unattainable combination. Scarcity then leads to what we call choice. Because we can't produce off all goods, we need to make a choice. For example, if I'm going from A to B, I'm making a choice, which is that rather than 50 of apples and 15 of oranges, I want now 40 of apples and 25 of oranges. So choice can be shown by the weighted combination on the PPC. Choice A would mean you can't get choice B or choice C, but all of these combinations are telling us the choices that we make. When we make choices, we are committing resources towards that. So for example, combination A tells us that we are putting resources so that we get 50 of apples and 15 of oranges, while combination B says that now I'm diverting resources and I'm getting choice B. So how do you show choice on the PPC? Well, simply by all your combinations on the PPC. Combinations on the PPC shows us what we call choice. Which brings us to the opportunity cost. What is opportunity cost? Well, we define that as the next best alternative forgone. In other words, it tells us that when we decide to have one particular choice, what do we lose out when we make that choice? So for example, if I look at the PPC, when I get more of oranges as I move from A to B, for example, here I get plus 10 of oranges, I am losing something of apples. I'm losing 10 of apples, right? That's where I move from A to B combination. So therefore, opportunity cost tells me, okay, how much do I lose of apples when I get more of oranges? And for that, our opportunity cost would be basically the slope of this curve. Why? Because slope by definition is your change in y over change in x, which in this case would be change in how much do I lose of apples, change in apples, because apples is on my y-axis. So change in, let me write this, apples over change in oranges in our case, because that's how our y and x-axis are. So which is minus 10 over plus 10 when I go from A to B, which means minus 1. So minus 10 over plus 10, this is plus 10, sorry for that, plus 10. So minus 1 would be my opportunity cost, which means that when I go from A to B, every time I get 1 of orange, I lose 1 of apple, because that's minus 1. And that would mean this is opportunity cost of oranges in terms of apples, right? So in short, the slope of the PPC tells us this opportunity cost. I want to show you one more example. Look at this. When I go from B to C, I'm getting how much of oranges, and the answer is plus 5. And how much I'm losing of apples, and the answer is minus 10. So the slope from B to C is going to be minus 10. Let me write this. Slope would be minus 10 over plus 5, which means now I'm losing, for every time I choose one apple, one orange, I'm losing 2 of apples. So the opportunity cost is in this case going up, but basically the slope tells us the opportunity cost. So just a quick recap: scarcity is shown by all the combinations beyond the PPC. Choice is shown by all the combinations on the PPC, A versus B versus C. And opportunity cost, which is the next best alternative forgone, is shown by the slope of the PPC, which tells us the sacrifice of what we make for more of one good in terms of less of another. Let's talk about economic growth. So how does PPC shows us economic growth? So what is economic growth? Economic growth is simply a rise in productive potential. So if there's a rise in productive potential, we will see economic growth to happen. And why will productive potential go up? And the answer is this, that if there is any sort of improvement in the quality or your quantity of factors of production. So any improvement in the quality or quantity of factors of production will lead to this economic growth. Which means that if your inputs become better or you have more of inputs, then suddenly you can produce more. And producing more would mean, let's say, for example, previously if I was making 50 of, for example, apples and 15 of oranges, and I was at combination A, economic growth would mean I can produce now more of both goods. For example, something like this would happen. The PPC will shift outward. So economic growth will be shown by a shift of the PPC to the right. So in fact, any shift of the PPC to the right would mean now we are not assuming A, technology being fixed, because like if the technology goes up, technology rises, we would see PPCs to shift, right? Similarly, we are changing our assumption about factors of production being fixed, because now if the factors of production improves in terms of its quality or quantity, then also your PPC is shifting to the right. Another thing that we need to talk about is that what can make the PPC shift to the left. Like if there's any decrease in the quality or quantity of factors of production, PPC will shift to the left. For example, let's say there is an earthquake in a country, or there is a natural calamity, and suddenly the factors of production, let's say 50% of your land gets destroyed because of, let's say, floods. And that would mean basically your productive potential will fall, which means PPC will shift backward. Right? So anytime there's an improvement in factors of production, PPC will shift to the right. Anytime there is a decrease in factors of production, PPC will shift to the left. Sometimes we see this kind of a curve in our exam. Now, this is what we call a pivotal shift. For example, if this was how your PPC was, and suddenly PPC shift to the right, where only the increase is seen in oranges and no increase is seen in apples. For example, previously if you're making, let's say, 50 and 15, for the same 50, for example, let's say if I tell you now you can get, let's say, 50, then you are looking at an improvement in one good only. So this can only happen if there is an improvement, if the productive possibility or productive potential goes up for only one kind of a good. This will result in a pivotal shift, and it means that only those factors of production relevant to the production of one good, in this case oranges, has improved. So for example, suddenly if land which is used for the production of oranges become more fertile, or for example the machinery which we use for oranges become more fertile, then there will be more production of oranges. The productive potential for oranges will go up. Now this means that the inputs that are used for apples have not shown improvement, but the inputs that are used for oranges have shown improvement, and that's why we are getting this non-pivotal kind of a shift. So non-pivotal shift means only those inputs which are relevant to one kind of a good have improved in quality. So our next discussion is about the shape of the PPC. The two kind of shapes that we'll see in exams. One is what we call a linear PPC, where what you can see here is just that it's a linear PPC, so the slope is constant. Or you'll see what we call this kind of a PPC, which is concave to the origin PPC, where we have what we call a slope which is rising. So there is a linear PPC with a constant slope, and there is a PPC which is concave to the origin, which is rising. Now I'm going to show you why. Because for example, if this is 50 and this is, let's say, 10, and if I go to 40, right, then this value might be, let's say, 15, and then let's say I go to another minus 10 to, like, say, 30, then I would get the same kind of an increase here in terms of oranges, like 20. So look at this. The slope is, when I look at this graph, let's say I go from A to B, minus 10 is here and then plus 5 is here. So the slope would be change in y or change in x, or minus 10 over plus 5, which means the slope is minus 2. So the opportunity cost is minus 2, which means every time I get one orange, I lose 2 of apples. But when I go from B to C, I get the same slope, because again, it's minus 10 over plus 5. So I get the same minus 10 over plus 5, which would mean I get the same slope of minus 2. This means slope is constant, which means basically what we're trying to imply here, that not only the slope is constant, but this is what we call a constant opportunity cost curve. Okay, the opportunity cost is not changing, and I'm going to talk about it in 1 minute, but let's look at the other curve first. Okay, now in this case, what is happening? Let's say if I am getting 50 and let's say 10, and let's say I go to minus 10 and go to 40, right, I might get, let's say, a plus 5. Okay, so let's say 15, so I get a plus 5. So what's the slope here? And the answer is, the slope is minus 10 over plus 5, which is equal to minus 2, right? But what if I go from, let's say, this is A to B, but what if I go to B to C? Now there's an important thing to look at, because now the distance here is shrinking. This gain here is shrinking for the same kind of a loss here. Let's say I go from 40 to 30, I get a minus 10, but here I'm just getting, let's say, 17 to plus 2, which means that every time I'm sacrificing the same level of apples, I'm getting less and less of oranges. The slope is like this. The slope is becoming more steeper, or the opportunity cost is going up, because look at what the slope is here. The slope here is minus 10 over plus 2, which means minus 5. The opportunity cost suddenly for one orange was like 2 apples, but now it's for one orange it's like 5 apples, which means the opportunity cost is rising. Slope is rising, or opportunity cost is rising. Now, why is this happening? Why is this opportunity cost rising here and the opportunity cost is constant here, and which one is more pertinent or realistic? And the answer is this, that this curve assumes that every time I go from more of oranges to less of apples, I'm diverting resources from the production of apples to oranges, but those resources that I'm diverting are equally efficient at producing both apples and oranges, which means, let me write this, equally efficient, which means that they are as good as producing, for example, oranges, as they are for producing apples. So we are not having any problem. The sacrifice is the same, irrespective of no matter how much oranges or apples you produce. On the other hand, this assumes that resources are not equally efficient, or in other words, not completely mobile. And it makes sense. For example, I go from production of apples to oranges. Now there's some conditions required for oranges to produce. So I can't really assume that every time I get to produce more of oranges by taking away resources which were very good for apples, I should get the same amount of oranges. There will come a point when those lands which were really good for apples but not good for oranges, if they are being used to make more oranges, clearly you will not get the same productivity that you were getting when you were making apples. So like minus 10 doesn't result in minus 10 plus 10 here, but only plus 2, because now that resource which was very good for apples is now used for oranges, which means that you will suddenly see a rising opportunity cost or a rising sacrifice, because those goods, those resources are not well suited for the production of oranges. So this one is more realistic. It says that you have a rising opportunity cost, which is what the reality is. People are not good at making everything, or not equally efficient or mobile in making all goods, while this one is simplistic. So both of these curves are relevant for as far as we're concerned, because they both come in our exam. The last thing we want to talk about is basically the application of PPC. Now, there are two kinds of applications we want to talk about. Number one is capital versus consumer good, which is basically, like if a country decides to put more of their resources in making capital goods, what is the opportunity cost in terms of consumer goods? And the second discussion we want to talk about is what we call capital consumption or depreciation. So let's start with first the capital versus consumer goods. So let's say a country is making two kinds of goods, either the capital goods or the consumer goods. Now, what are capital goods? We say capital goods are those goods which are useful in the production of, or rather they are inputs in the production of other goods. So for example, machinery could be capital goods. And consumer goods are those goods which are basically consumed for, so let's say by a consumer, and it is a good which doesn't help us produce more of other goods. Like for example, a bar of soap would be a consumer good, burgers would be consumer goods, and so on. While the machinery that is used to make those burgers will be your capital good. So I have two countries, let's say country A versus country B, and country A is deciding to put more of their resources in capital goods and less on consumer goods, versus country B is putting more on consumer goods and less on capital goods. So this is a choice that two countries, let's say country A and country B has made. So country A is putting more on capital goods. This means they are right now deciding to sacrifice consumer goods for more capital goods. This sacrifice of consumer goods would mean they will have a lower living standard today. Why? Because a country that is investing in capital goods and has a lower amount of consumer goods are directly linked with your welfare or your standard of living. So they decide to have low of your consumer goods, and therefore they are not having higher living standard, only because they want to invest more in capital goods. Remember, capital goods are investments as well. Why are they investment? Because this is where we are producing more of capital goods. Now, country B, on the other hand, decides to have more of consumer goods. This means that they have a higher living standard today, but less of capital goods means they're not putting enough money or resources in the production of capital goods. What's the implication of this? And the answer is, the implication of this is that country A might achieve economic growth, because remember, economic growth is improvement in the quality or quantity of factors of production. So country A might go to, let's say, A dash, while country B, on the other hand, may achieve lower economic growth to, for example, B dash. What we're trying to say is that there is a trade-off. The trade-off or opportunity cost is that if you decide to have more of capital goods today, you might sacrifice consumer goods today, but you will be able to achieve more economic growth than another country that is putting less resources on capital goods today. So the trade-off is something, has a name which we say is more jam today versus more jam tomorrow. What do we mean by this? If I decide to have more jam today, jam is a consumer good, of course, then this would mean I am right now country B, then I would have less jam tomorrow than another country, like country A, that decides to have less jam today, less consumer good today, but more consumer goods tomorrow, because they have achieved higher economic growth. So a country has to make a choice as to decide how much of their input should they dedicate to capital versus consumer goods. And there is an implication, because if you put more resources in capital goods, you achieve more economic growth, higher shift of the PPC to the right. While if you put less resources on consumer on capital goods, then this would mean lower economic growth in the future. Let's talk about depreciation or capital consumption. So what is capital consumption or depreciation? Well, we define depreciation as when capital gets used and need to be replaced. So if a country is using resources and in the process of using it, it ends up depleting those resources, then the most important thing would be to replace them so that the capital stock or the amount of capital goods that you have stays the same. Because if the amount of capital goods stays the same, then your productive potential remains the same. And if your productive potential remains the same, then the PPC will not shift backward or will not shift to the left. In fact, if you invest more than your depreciation or capital consumption, you are basically not only replacing your capital stock but also putting more money in new capital, and that will see economic growth. So let's say a country right now has OA amount of capital goods being used in terms of or being depreciated. Okay, this is your amount of what we call depreciation. Let me call it DIP. This is the amount of depreciation. Now, if you are able to invest OA, you will stay at this PPC. But let's say you decide not to put OA, but let's say you decide only to put OB amount of capital stock. This means that you're not putting enough. There is this much of depreciated capital, which means this much of investment needed, and you decided not to put this much, but you decided to put something lower like OB. Why? Because you decided to have more of consumer goods. So you're trying to have more of consumer goods. So let's say you decided to be at this point, right? Now, the result of this more of consumer goods today at the expense of capital goods would be not good for the economy, because now suddenly you don't have enough capital stock and your PPC will as a result shift backward. Does that make sense? So in order for us to make sure that your PPC stays at the same point, we need to invest enough to make sure we are taking care of your capital that is being used up. We need to replace that. In fact, if you decide to put more than OA, you might see PPC to shift to the right, because now you are not only replacing your depreciated asset, but also putting more. So what is the conclusion here? Well, an economy needs to invest at least enough to make sure that they are able to replace their depreciated capital. If they do so, PPC stays where it is. If they don't do that, PPC will shift backward. Or if they invest more than the depreciated amount, let's call it let's say C, then you will be able to actually see PPC to shift to the right, because you are increasing the inputs or increasing the productive potential or increasing the quantity of your factors of production.